Hello grade 11 students. Today I am here to teach you a new topic to you, that's Matrices chapter 19. So the idea of matrices introduced by a British mathematician Arthur Cayley. So we'll see what are matrices. So before that we'll take this example. Sama has 3 blue pens and 2 red pens. Ganesh has 4 blue pens and 1 red pen. Mohammed has 5 blue pens and 3 red pens. So when you write like this, it's very difficult to understand. So we are trying to make tables. So how we can arrange this idea in tables? So we can take one side pens, pen color, and the other side Sama, Ganesh and Mohammed. So we'll arrange this data in a table. So I can write Sama, Ganesh here, and who's the other person? Mohammed. And this side I can write down the color. So here I can write the color of the pen, and this is people. So what are the colors? Blue and red. Now count. Now we can fill the table. Sama has 3 blue pens and 2 red. Ganesh has 4 blue pens and 1 red pen, and Mohammed has 5 blue pens and 3 red pens. So one can arrange the other way around. So people this way and the color of the pen this way. So then it comes like blue, red, and here Sama, Ganesh and Mohammed this way. Then how can we fill this? So Sama 3, 2, Ganesh 4 blue and 1 red, Mohammed 5 blues and 3 red. So this mathematician thought, without arranging in a table, if we can arrange only the numbers in rows and columns, it's easy to understand, and those are matrices. So matrices are array of numbers arranged in rows and columns. So I can write without this table with 2 brackets like this, and I can write 3, 4, 5, 2, 1, 3. This also I can write in brackets. I can write in brackets 3, 2, 4, 1, 5, 3. So these are called matrices. So in singular form we say matrix. So matrices are array of numbers arranged in rows and columns. So what are rows? So we take rows are horizontal way, we call those are rows. So this way we call rows. Then this way columns are vertical like. So this way we call columns. In a matrix you need to know columns and rows. Now we'll look at this matrix. So with brackets you put numbers. How many rows are there? Horizontally you get 2 rows. I'll write 2 rows. And how many columns? 1, 2, 3. 3 columns are there. What you call these numbers? Numbers in a matrix we call elements. So 2 is an element, 7 is an element. So elements are these numbers. So like in a set, we write in curly brackets, we write all the elements in the set in curly brackets. So likewise, we write the elements in a matrix in rows and columns. How we can label the matrices? So we use capital letters to represent the matrix. A is equal to. So this is the A matrix. This is B matrix. And this is C matrix. So how many rows there? 2 rows. How many columns? 3 columns. This one, how many rows? 1, 2. 2 rows. And how many columns? 1, 2. 2 columns. This one, how many rows? This way horizontally 2 rows and 2 columns. Then you need to know what is an order of a matrix. Order means the size of a matrix. Size of a matrix. So what we do, we first count number of rows, number of columns, and then we write down the order. So how many rows are there? 1, 2. 2 rows. And how many columns? 1, 2, 3. 3 columns. So what we do here, we first take rows. So this is 2. And then we use the multiplication sign and write down number of columns. 2 by 3. That's how we pronounce, not 2 multiplied by 3. If you are asked to write down the order, we write 2 by 3 matrix. Number of rows here and number of columns. Don't mix these two because always first thing you have to write down number of rows. So that's called order of a matrix. Write down the order of the following matrices. Now count how many rows? 2 rows. How many columns? 2 columns. What's the order? 2 by 2 matrix. This one? How many rows? 1, 2. How many columns? 1, 2, 3. 2 by 3 matrix. Now take this one. 2 rows are there. 1, 2, 3, 4. 4 columns. 2 by 4 matrix. 3 rows and 3 columns. 3 by 3 matrix. So what is row matrices? Row matrices means only you get one row. Any number of columns but only one row we call row matrix. Only one row in the matrix. Look at the matrix, only one row and 3 columns. So how can you write down the order? 1 by 3. This one, Q matrix, 1 row and how many columns? 1, 2, 3, 4, 1 by 4. So for a row matrix, first number is always 1. Column matrices, other way around. Only one column. You get number of rows but only one column. Then how can we write down the order? Take the P matrix. 3 rows are there but 1 column. 3 by 1. 1, 2, 3, 4. 4 rows are there. 1 column. 4 by 1 matrix. So when it's a column matrix, you get the second number always 1. Then you need to know what are square matrices. If the number of rows and number of columns are the same, we call those are square matrices. So I'll write down number of rows and columns are equal. So square, that's why we call it square. So this one is 1 row, 1 column, 1 by 1. 2 rows, 2 columns in B, 2 by 2. 3 rows, 3 columns, 3 by 3. 4 by 4. So this number and this number both are equal. Number of rows are equal to number of columns. Then what are zero matrices? Zero matrix means all elements in the matrix is all the elements are zeros. So here P is a matrix, all the elements are 0. Q is another matrix, all elements are 0. So in all these examples, elements are 0. So what are 0? All elements are zeros. So what's the size? Order. Just write down the order here. 2 by 2. This one 3 by 1. Column matrix. This is a row matrix. 1 by 3. This is 3 by 3. So this is a square matrix but 0. Elements, all elements are 0. This is a square matrix with all elements are 0. Then you need to identify what's the main diagonal term. So we take the left hand side, the uppermost value with the lowermost value on the right hand side. So when you connect that, you get the main diagonal term. So this is the main AB is the main diagonal in this 2 by 2 matrix. Take this one. So same thing, this is in a table, this is in a matrix 2, 1, 4, 3. So this is called, this way is called the main diagonal. So you need to identify the main diagonal term. The 2 and 3 are the elements in the main diagonal here. Here 3, 7, 8. So what's the main diagonal? Left hand side uppermost value with the right hand side lowermost value. Identity matrix. When you look at these, you can identify. Some ones are there and all the other terms are zeros. So what you call this one? So the main diagonal term. when you get main diagonal term ones and all the other elements are zeros, we call those a identity matrix. So we denote this by letter I. Capital I stands for identity matrix. So this is the order 2 by 2, 2 rows and 2 columns, and here you will understand this is main diagonal terms are ones. So I'll write down in identity matrix main diagonal elements are ones and all the other elements are zeros. So that's what we say about identity matrix. Then symmetric matrix. So symmetric matrix only occurs in square matrices. Only when you get a square matrix, only for a square matrix you get symmetric matrix. So when you take the main diagonal, you can see this is like the mirror line. All the other elements are the same, corresponding elements. When you draw the main diagonal term, other elements are zeros here. So these are symmetric matrices. Symmetric matrices are when you get the main diagonal term, all the other elements are the same. So main diagonal terms are in a mirror line. So this is like reflection. You are getting the same on the other side as well as this side. Here 3 by 3, this is a identity matrix. So identity matrices are all symmetric matrices. Equal matrices. Now take this example. A is given this matrix and B is given this one. So corresponding elements. So the size of A is, what's the size of A? 2 by 2. What's the size of B? What's the order? 2 by 2. When you compare corresponding elements in each matrix, you get the same. 3 here, 3, 5, 5, 1, 1, 8, 8. So we say these two are equal matrices because corresponding elements are the same. So we can write A equals B. A matrix is equal to B matrix. So the sizes, the order is also the same. Take this one. Check whether these are equal matrices. 3 here, but can you see? These two are not equal. So because of this, P and Q are not equal matrices. But in this case, A and B are equal matrices. Now we will do some of the examples. Represent the following information in matrix. So these are in tables. So how can we write down in matrix form? So we take 2 brackets and write down the elements inside. 2, 3, 4, 1, 8, 4. How many rows? 2. How many columns? 3. 2 by 3 matrix. This one 2 rows and 2 columns. So what's the matrix there? 3, 5, 2, 9. I can write this is 2 by 2 matrix. Now write down this one in a matrix form. 1, 0. Here this is a mistake. 1 should be below. So this line should be up. 1, 0, 2, 5, 7. 1, 0, 2, 5 and 7, 7. So how many rows? 1, 2, 3, 2 columns. 3 by 2 matrix. Write down the order of the following matrices. So write down, first count how many rows, how many columns and write down. So 2 rows, 3 columns, 2 by 3. 2 rows, 2 columns, 2 by 2. 3 rows and 2 columns, 3 by 2. And this one, it's a row matrix, only one row there. So 1 row and 3 columns, 1 by 3 matrix. What's this one? A column matrix. 4 rows are there and 1 column. 4 rows and 1 column, 4 by 1. Here 3 rows, 3 columns, 3 by 3. This one 2 rows and 1, 2, 3, 4. 2 by 4 matrix. So write down the order there. 2 rows, 1 column. 2 by 1. 3 rows, this one we missed that. 1 row, 2 columns. 1 by 2. This is a row matrix. 3 rows, 1, 2, 3, 4. 4 columns. 3 by 4. 1, 2, 3, 4, 5. 5 rows and how many columns? 1 column. This is a column matrix. So you have given several matrices A, B, C, D, E, F, G, H. Select square matrices from the above given information. So what are square matrices? Number of rows and columns are the same. 2 rows will first identify the order. 2 rows, 3 columns. 2 rows, 2 columns. 2 by 2. 2 rows, 2 columns. 3 rows, 3 columns. This one, 1 row, 1 column. 3 rows, 2 column. 3 rows and 3 columns. Here 2 rows and 1, 2, 3, 4. 4 columns. Now identify square matrices. Number of rows and number of columns are the same. 2 by 2, 2 by 2. This one D. 1 by 1 also number of rows and number of columns are the same. This one. So we can write B, C, D, E, G. Those are square matrices. Write down following identity matrices. I 2 into 2 by 2. What is 2 by 2 means? 2 rows and 2 columns. The main diagonal elements are ones and all the other elements are zeros. So this is 2 by 2. Write down 3 by 3 identity matrix. All the leading diagonal, sometimes we call leading diagonal terms. all main diagonal terms are ones and the other elements are zeros. So this is 3 by 3. So all identity matrices are what you call square matrices, or we can say symmetric matrices. 4 by 4, main diagonal terms are ones and all the other elements are zeros. So this is 4 by 4 identity matrix. Identify symmetric matrices. What are symmetric matrices? When you take the leading diagonal term or main diagonal term, all the other elements are the same. So take the leading diagonal term, the other two elements are the same. So A is a symmetric matrix. Take B, when you take the main diagonal term, 1 and 7 are not the same. So that's not a symmetric matrix. This one, when you take the leading diagonal term or main diagonal term, elements are the same. So C is a symmetric matrix. This one, when you draw the leading diagonal term or main diagonal term, 3, 5, 6. So D is also a symmetric matrix. E, 0, -3, 5. So E also symmetric matrix. F, 9 there, 3 here. These two numbers are not the same. So that's not a symmetric matrix. Find ABC for a symmetric matrix. So when you draw the leading diagonal term or main diagonal term, these elements are the same. So what's the A value? To get a symmetric matrix, A should be 3 here. What's the B value? B should be 4 and C should be 7. So that's how you identify a symmetric matrix. Now here, can you get a symmetric matrix for this one? Can you? No, this is for the equal matrix. So here I'll write down the question because this is 2 by 3. In 2 by 3 you can't get a symmetric matrix, only for a square matrix. So this one, to get A equals B, what should be the values for ABC? To get A equals B, 2 is there, 5, 3. So corresponding elements are the same. If A equals B, A should be 3. Here B should be 1, 4 is there, and C should be 7. So this is for equal matrices. Find A and X when P equals Q. These two are equal. So 3 is there, 7, 1. So what's the A value? A is 1. X equals 8. Find the value of the unknowns. These two matrices are equal. So compare the corresponding elements. A is 2, B is this one -7, C is this one 8, and 3 is already there. Now these two are 3 by 3 matrices and equal. So what's X? X is this number, so that's equal to 9. Y is this number, that's equal to Z is this number, last digit, that's 9. All the other corresponding elements are the same. Look at these two equal matrices. A is -3. B, compare, that's 2. C is 4. D equals 7. Now this one, 2x equals 8 now. 2x equals 8. So what's x? 8 divided by 2, you get 4. This element is equal to this one. 3y equals 9. What's y? 9 divided by 3, you get y is 3. Now this one is just A equals 3. Look at these two matrices, equal matrices. A should be 5. B is 6. C, compare these two. C is 7. D is 0. Now this one, what are the values? So you are comparing these two rows and 2 columns. So this element is equal to this one. So we can write down x plus 2 equals 6. So what's x? Take 2 to the other side, x becomes 4. And this whole thing, y minus 1 is equal to 7. So what's y? Y minus 1 equals 7. So y equals, take minus 1 to the other side, that's 8. Equal matrices, and you are asked to find out A and B. Half A, this half A is equal to 2. Then multiply by 2, you get A equals 4. Then look at B. 1/3 of B is equal to 4. 1/3 of B equals 4. What's the B value? 4 times 3, 12. So B equals 12. Addition of matrices. When you get two matrices, we'll see how we can add these two. So the first important thing in addition is the number of elements. The rows and columns should be the same. Basically, order needs to be the same thing. So what's the order here? 2 by 2. What's the order here? 2 by 2. So we can add only when the order of matrices are the same. So we'll write down, can add only the order of the matrices are the same. Can we add A and B? 2 by 2, 2 by 2, so we can add. So what we do? We add corresponding elements. 2 with 1, 2 plus 1. So when you are adding corresponding elements, we add 2 and 1, that's 3. 1 plus 0, 1. 3 plus 3, 6. 5 plus 4, 9. So the resulting matrix also 2 by 2, same order. Now we'll do other way around. First A plus B, now B plus A. So B first and then A. Same thing, corresponding elements we add. 1 plus 2, you get 3. I'll write down here 1 plus 2, 0 plus 1, 3 plus 3 and 4 plus 5. What are the numbers? You get 3, 1, 6, 9. 3, 1, 6, 9. What can you say about these two matrices? A plus B is same as B plus A. So, order is not important. Order means the arrangement is not important when you are adding matrices. So, we can write A plus B is same as B plus A. Take these two matrices, 2 by 3 is the size. This is also 2 by 3. Now add P plus Q. Corresponding elements you have to add 2 plus 0, 2. 1 minus 1, 0. 3 minus 2, 1. 1 plus 1, 2. 4 plus 2, 6. 5 plus 5 minus 1, you get 4. So, this is 2 by 3 matrix. Now, we will do other way around. Q first. 0 plus 2, 2. Minus 1 plus 1, 0. Minus 2 plus 3, 1. 1 and 1 becomes 2. 2 plus 4, 6. Minus 1 plus 5, you get 4. Now, look at these two. This is also 2 by 3. Look at these two. You get the same matrix. So, we can write P plus Q is same as Q plus P. Add the following matrices. So, what you do? 2 by 2 given. First, check whether you can add same order. When you get same order, you can add 2 plus 1, that's 3. This is also 2 by 2. 1 plus 3, 4. 3 plus 2, 5. 4 plus 5, 9. This one, 3 rows, 1 column. 3 rows, 1 column. You can add 3 plus 1, 4. 1 plus 2, 3. 4 plus 3, 7. This is a row matrix. 1 into 3. 1 into 3. So, the resulting one is also 1 into 3. 2 plus 1, you get 3. 4 plus 0, 4. 3 plus 2, 5. Now, add these two. You have given 3 by 3 matrices. So, the resulting also 3 by 3. Corresponding elements you can add 1, 1, you get 2. 2, 2, you get 4. 3 plus 3, 6. 7 plus 7, 14. 1 plus 1, 2. Minus 2, minus 2 adding, minus 4. 3 plus 3, 6. Minus 1, you get minus 2. 5 and 5, you get 10. This one, this is a 2 by 2 matrix. This is also 2 by 2. The resulting matrix also 2 by 2. Add the corresponding elements. 3 plus 1, you get 4. 7 plus 2, 9. 1 plus 7, 8. And 4 minus 1, you get 3. Now, subtraction. So, you need to understand this. When it comes to addition or subtraction, the order of the matrices should be the same. So, this is 2 by 2, this is 2 by 2. So, you can subtract. So, what's A minus B? We will do A minus B. 3, 5, 1, 4 minus 2, 1, 0, 3. What's the matrix? 3 minus 2, you get 1. 5 minus 1, 4. 1 minus 0, 1, and 4 minus 3, 1. So you are getting A minus B, 1, 4, 1, 1. Now we'll do B minus A. What do you think? Do you get the same matrix? We'll see. B first. 2, 1, 0, 3. 3, 5, 1, 4. Now subtract. 2 minus 3, you get minus 1. 1 minus 5, minus 4. 0 minus 1, you get minus 1. 3 minus 4, minus 1. Now compare these two. Do you think you are getting the same matrix? No. You are not getting the same thing. When it's addition, you get the same answer. But when it comes to subtraction, it's not equal. So A minus B is not the same as B minus A. So remember that only for addition you can add any matrix first. Subtract the following matrices. So you have given two matrices, A and B, and you are asked to subtract. So we'll first write A, 2, 3, 1, 4, 1, 3, 0, 4. Both are 2 by 2 matrices. Now we'll subtract. 2 minus 1, you get 1. 3 minus 3, 0. 1 minus 0, 1, and 4 minus 4, you get 0. Now we'll take B minus C. Same example now, B minus C. First write B, 1, 3, 0, 4. Then C, 1, 4, 3, 5. Now subtract. 1 minus 1, 0. 3 minus 4, minus 1. 0 minus 3, you get minus 3. 4 minus 5, minus 1. So B minus C is this same order 2 by 2. This one A minus C. So we have to write first A, 2, 3, 1, 4. C is 1, 4, 3, 5. Now subtract. Corresponding elements you have to subtract. 2 minus 1, 1. 3 minus 4, minus 1. 1 minus 3, minus 2. 4 minus 5, minus 1. B minus D. B first. 1, 3, 0, 4. D, 2, 1, 3, 3. Subtract. 1 minus 2, minus 1. 3 minus 1, 2. 0 minus 3, minus 3. 4 minus 3, you get 1. D minus B now. You write D first and then B. 1, 3, 0, 4. Now subtract. 2 minus 1 is 1. 1 minus 3 minus 2. 3 minus 0, 3. 3 minus 4, minus 1. Now we'll take A minus A. 2, 3, 1, 4. 2, 3, 1, 4. What happens? All elements are 0. 3 minus 3, 0. 1 minus 1, 0. So you are getting a 0 matrix when you subtract the same matrix. B minus B. 1, 3, 0, 4. 1, 3, 0, 4. So what you get here? 0 for all elements. C minus C. 1, 4, 3, 5. 1, 4, 3, 5. So when you subtract, you get all elements 0. Now we are trying to multiply. So we did addition and subtraction of matrices. So the order should be the same to add or subtract. Now we will see how we can multiply. First we will multiply a matrix by a number. So take this example. A is given 2 by 2 matrix 2, 3, 1, 4. So you are asked to find out 2A and 3A. So when you are taking 2A, you can either add two matrices. A plus A becomes 2A. So we will do that way. 2, 3, 1, 4, 2, 3, 1, 4. So what's the answer? 2 plus 2, 4, 3 plus 3, 6, 1 plus 1, 2, 4 plus 4, 8. Now we'll see another method. 2A I can multiply all the elements by the number there, 2. So 2 times 2, 2 times 3, 2 times 1 and 2 times 4. So 2 times 2, 4, 2 times 3, 6, 2 times 1, 2 and 2 times 4, 8. Now look at the two answers. You are getting the same thing. So which one is easy? Just multiply all the elements by that number is easier than adding separately. So if you have 5, you have to add 5 matrices. So it's difficult. So it's easy just to multiply by the number. Now we'll take 3A. 3A means you multiply all the elements by 3. 3 times 2, 3 times 3, 3 times 1, 3 times 4. So what are the numbers? 3 times 2, 6, 3 times 3, 9, 3 times 1, 3 and 3 times 4, 12. Now we'll take P. P, you are asked to find 1/3 P. So what you do? To get 1/3 P, we write 1/3 there and write down the P matrix. Each number you have to divide by 3. 1/3 means divide by 3. So 3 divide by 3, 6 divide by 3, 9 divide by 3 and 12 divide by 3. 3 divided by 3 is 1. 6 divided by 3, you get 2. 9 divided by 3, 3 and 12 divided by 3, you get 4. This one, you are getting two matrices, that 2 by 2. You are asked to find out 2A plus B. So what we do? We have to multiply all the elements in A by 2 and then add it to B. So when you multiply by 2, what you get? 2 times 3, 6. 2 times 2, 4. 2 times 1, 2. 2 times 5, 10. Now add corresponding elements. 6 and 1, 7. 4 and 0, 4. 2 and 2, 4. 10 plus 3, 30. So you are getting 2A plus B as this one. 2, same thing, second part. Now you are asked to find out 3A plus 2B. So what you do? 3 times A is 3215, B is 1023. Now multiply by 3. 3 times 3, 9, 3 times 2, 6, 3 times 1, 3, 3 times 5, 15. 2 times 1, 2, 2 times 0, 0, 2 times 2, 4, 2 times 3, 6. Now corresponding elements you can add. 9 plus 2, 11. 6 plus 0, 6. 3 plus 4, 7. And 15 plus 6, 21. This one, part 3. Now 3A minus 2B. So you multiply by A first. 3A, 3215. B multiply by 2 and then subtract 1023. Now multiply 3 times 3, 9. 3 times 2, 6. 3 times 1, 3. 3 times 5, 15. This one, 2 times 1, 2, 2 times 0, 0, 2 times 2, 4, 2 times 3, 6. Now subtract the two matrices. 9 minus 2, 7. 6 minus 0, 6. 3 minus 4, you get minus 1. 15 minus 6, 9. Now another part. Now we want 5a minus 3b. So same question, we want 5a. So 5 times a, 3, 2, 1, 5, and 3 times b, 1, 0, 2, 3. So what we do? Multiply all the elements by 5 here. 5 times 3, 15, 5 times 2, 10, 5 times 1, 5, and 5 times 5, 25. Here multiply by 3. 3 times 1, 3, 3 times 0, 0, 3 times 2, 6, and 3 times 3, 9. Now subtract. 15 minus 3, you get 12. 10 minus 0, 10. 5 minus 6, minus 1. 25 minus 9, 16. Another example, you have given P 3, 2 and 4, 5. What's the size? Order of the matrix? 2 by 1. This is also 2 by 1. You can add the two matrices. So first part, 2p plus 3q. So what you do? 2 times p plus 3 times q. If you can add straight away, do it. No need to write down separately. So if you can do 2 times 3, 6, 3 times 4, 12, 12 plus 6, 18, you can do that. I'll write it separately. 6, 4 plus 12, 15. Then what you get? You get 6 plus 12, 18, 4 plus 15, 19. 18, 19. Second part, 3p minus 2q. 3 times p minus 2 times q. 3 times 3, 9. 3 times 2, 6. Then subtract. 2 times 4, 8. 2 times 5, 10. So what's the matrix you are getting? 9 minus 8 is 1. 6 minus 10 minus 4. Third part, 5p minus q. That means 5 times p. P is 3, 2 minus q is 4, 5. What's the value? 5 times 3, 15. 5 times 2, 10. Minus. Here just we can subtract 4, 5. 15 minus 4, you get 11. 10 minus 5, you get 5. Another question, find A, B, C, D when B equals A. So equal. This is B and you can write down this is 2, 3, 1, 5. So this is B equals A is this. Now we can write down what are the numbers. Corresponding elements are equal. A equals 2, B equals 3. C is 1 and D equals 5. Now we will see what is multiplication of matrices. So I'll take an example. Take this example. Mala buys 3 apples and 2 oranges and Sama buys 2 apples and 1 orange. And we know that when you take the prices, 1 apple is 30 rupees and 1 orange is 20 rupees. How we can find out the amount spent by Mala and amount spent by Sama? So what we are doing? We are multiplying 3 apples, each 30, and add 2 oranges, each with 20 rupees. So what's the total? 3 times 30, 90. 2 times 20, 40. 90 plus 40, you get 130 rupees. This is for Mala. And for Sama, I can do 2 apples, each 30 rupees, and 1 orange worth 20 rupees. So what's the amount Sama paid? 60 plus 20, 80 rupees. 80 rupees. So how we can arrange this in a matrix? So same concept, we are trying to use multiplication. So I can write the matrix Mala and Sama both. I can write 3 apples, 2 oranges, and 2 apples and 1 orange. And what's the price of 1 apple? 30 rupees, and the other one is 20 rupees. So if I take, this is the first matrix and this is the other matrix, now I can find out the same amount using this one. So think about, earlier we got 3 with 30, 2 with 20, 2 with 30 and 1 with 20. So what happens here? This is for Mala. So we take the row and the column. 3 with 30. First row, first column number multiplied by first row, first column number. This is first row, second column multiplied by second row, first column. Here this is second row, first column, second row, second column. So you are multiplying like that. So that's how you get the value. Now I can rewrite this 3. So same thing, 3 with 30 plus 2 with 20. Here for Sama, 2 times 30 plus 1 times 20. So we got the resulting matrix as 130 and 80. Now we'll look at the order of these matrices. What's the order here? 2 by 2. What's the order here? 2 rows, 1 column. 2 by 1. And here, what's the resulting matrix? You get 2 rows and 1 column. So when you get multiplication, what happens? You have to check the number of columns in the first matrix and the number of rows in the second matrix. These two numbers should be the same for multiplication. So what's the theory? When you want to multiply two matrices, the number of columns in the first one is the same as the number of rows in the second matrix. Then only you can multiply, and the resulting matrix you are getting with the other two numbers. 2 by 1 is the resulting matrix. So we'll see with several examples how we can multiply. So this is important in multiplication. Number of columns in first matrix number of columns in the first matrix and number of rows in the second matrix are the same. So this condition should be satisfied for multiplication. Now we'll take this matrix. What's the size? 2 by 2. What's the size here? 2 rows, 1 column, 2 by 1. Can we multiply? Check these two numbers. Both are the same, so you can multiply. What's the resulting matrix? You will get 2 by 1 matrix. So these two numbers are the resulting matrix. So what we do? We take the row, multiply with the column. Take the first row, multiply with this one. 2 times 30 plus 3 times 40. Next one, take the second row, multiply by the column. So what you get there? 1 times 30, 2 times 40. What's the answer? 2 times 30 is 60 plus 3 times 40, 120. 1 times 30, 30, 2 times 40, 80. Now add 60 plus 120, you get 180. And 30 plus 80, you get 110. So the resulting matrix is 180 and 110. You get 2 by 1 matrix. Now try to multiply this A times B. Here without writing multiplication you can write AB, same as A multiplied by B. We will see whether we can multiply. 2, 3, 1, 2. 30, 40, both are the numbers. So we will check with the order. This is 2 by 2. This is 2 by 1. These two numbers are the same, so you can multiply. What's the resulting matrix? You are getting 2 times 1. What is 2 times 1 means? 2 rows and 1 column. So 2 numbers you are getting. So how we find out these two numbers? First row with first column. So 2 times 30. I'll write down. I'll take space there and write down here. So what's the space there? 2 times 30 plus 3 times 40. This one, 1 times 30, 2 times 40. So what's the final matrix you are getting? 2 by 1, that means 2 values you are getting, 2 rows with 1 column. 2 times 30, 60, 60 plus 120. 60 plus 120, you get 180. 30 plus 2 times 40, 80, 80 plus 30, 110. So AB is this matrix. Now we'll take this one and you are asked to find out AB first. A first and then B. So this is 2 by 2, 2 by 2. You can multiply. So what's the resulting matrix? Again 2 by 2 matrix. So how we multiply? First row with first column. 2 times 1 plus 3 times 3. Then what you do here? First row, second column now. 2 times 2, 3 times 4. This one, 1 times 1, 4 times 3. Last one, second row with second column. 1 times 2, 4 times 4. Now we'll find out the values. 2 times 1, 2 plus 9. 4 plus 12. 1 plus 12. 2 plus 16. So what are the values? 9 plus 2, 11. 4 plus 12, 16. 13 here and 18. So A, B is that. Now we'll take BA, B first and see what happens. This is also 2 by 2, 2 by 2. You can multiply. So the resulting matrix also 2 by 2. First row, first column. 1 times 2, 2 times 1. This one, first row with second column. 1 times 3, 2 plus 2 into 4. Second one, second row with first column. 3 times 2, 4 times 1. Last one, second row with second column. 3 times 3, 4 times 4. 4 times 4. Now, simplify. 1 times 2, 2. 2 plus 2. 3 plus 8. 6 plus 4. 9 plus 16. So, what's the resulting matrix? 4, 11, 10 and 25. Now, what can you say about AB and BA? Do you get the same matrix? You are not getting the same matrix. So, what happens here? These are not equal. So, AB is not equal to BA. In addition, you can write in any order, A first or B first. But in multiplication, the starting letter is important. When you start with A and when you start with B, you get two different matrices. So, in multiplication, the order means the arrangement of the matrices are important. Look at these two. See whether you can multiply. P is 1 by 3. Q 3 by 1. So P first, PQ this way. So number of columns and number of rows are the same. So you can multiply. What's the resulting matrix? You get PQ as 1 by 1 matrix. That means just one number. So how we get that number? First row with first column. 1 times 1 plus 2 times 3 plus 4 times 0. So what's the number? 1 times 1 is 1, 2 times 3, 6, 4 times 0, 0. So the final matrix is 7. So that's 1 by 1, just a number. Now PQ given, what's order of P? 2 rows, 3 columns. What's the order of Q? 3 rows, 2 columns. Now we need PQ. Can we multiply? These two numbers are the same. So we'll write first P, 2, 1, 3, 0, 2, 4. Q, 1, 1, 0, 1, 3, 0. And we'll do the calculations. I'll write down here what's the resulting matrix. That's 2 by 2. So what we do? First row, first column. 2 times 1, 2, 0 and 9. 2 plus 9, 11. So I'll show you how you can write down 2 times 1 plus here 1 times 0, 0, no need to write. 3 times 3 here. Then what's the next number there? 2 times 1, 2, 1 times 1, 1, 2 plus 1, 3, because this becomes 0. So you are getting 3 here. We'll write down that 2 times, I need space there, 2 times 1 here and then 1 times 1. 2 plus 1, 3. Now take the next one, 0, 0, 12. So you are getting 12 there. So try to do at once. So I'll write down what you get here, 4 times 3. Now last one, second row with second column, 0, 2, 0. So the answer is 2. I'll write down 2 times 1 comes there, other terms get zeros. So that's how we multiply. So what's the resulting matrix? 2 by 2. X, Y, two matrices are given. We'll see whether we can multiply. 3 rows, 2 columns. This one, 2 and 2. So we can multiply x into y. So what's the resulting matrix? X into y becomes 3 times 2. 3 rows and 2 columns. So how we get the numbers? First number, first we'll write down the two matrices, 3, 5, 2, 4, y, 2, 1, 3, 7. Now what we do? Try to do at once. You need to get 3 rows and 2 columns. So how many numbers you need to get? 1, 2, 3, 4, 5, 6 numbers you need to get. Now we'll do it. First row, first column, 2, 6, 2 plus 6, 8. This one, so first row with second column, 1, 14, 1 plus 14, you get 15. Second row with first column, 6, 15, 15 plus 6, 21. This one, second row, second column. 3 and 35. 35 plus 3, 38. Next one, 4 and 12. 4 plus 12, 16. 2 and 28. 28 plus 2, 30. See whether you can get the answers at once, because no need to write down separately the numbers. If you can take your hand and just do always first row, first column, first row, second column. So this way. Then second row, first column, second row, second column. Then last one becomes third row, first column, third row, second column. Two matrices are given. You are asked to find AB. Can we multiply 3 by 3, 3 by 2? We can. What's the resulting matrix? You get 3 by 2. We'll write down 2, 1, 3, 0, 1, 2, 1, 3, 4. B 3, 1, 2, 0, 4, 2. Now use the method. So 3 by 2 means 3 rows, 2 columns. So you need to get 6 numbers. How you get the first number? First row, first column. 6, 2, 8. 8 plus 12. What is 8 plus 12? 20. 2, 0, 6. 2 plus 6, 8. 0, 2, 2 plus 8, 10. Then the other one, second row, second column. 0, 0, 4. This one, 3, 6. 3, 6, 16. 3, 6, 16. What's the addition? 25. 1, 0, 8. 1 plus 8, you get 9. Let's take this example. You have given two matrices and you are asked to multiply. And this side, another matrix given, you are asked to find out x, y, z. So we'll first multiply and write down here. So this is 2 by 2, 2 by 2. So the resulting matrix also 2 by 2. We'll do the calculation. 0, 2y. This one 0, 0. This one second row, first column, minus x, 0. This one minus 1 into minus 3, 3. So you get 3 there. So 2y, 0, minus x, 3. Other side, you have to add it. First you multiply all the elements by 2. 2, 8, 2 times 0, 0, 2 times minus 1, minus 2. Then add it to 6 minus 8, 5, 3z. What's the value you are getting? 2 plus 6, 8. 8 minus 8, 0. 0 plus 5, you get 5 here, minus 2 plus 3z. Now these two matrices are equal, so you can compare. 2y is equal to 8. So what's y? 8 divided by 2, you get y equals 4. This number is here. Minus x equals 5. So what's x? X equals minus 5. So this is minus 5. Then last one. This element is equal to this one. So 3 equals minus 2 plus 3z. Take minus 2 to this side. 3 plus 2 becomes 5 is equal to 3z. And then divide by 3. Z equals 5 divided by 3. So, you get 5 divided by 3 as z. A and B given and you are asked to find multiplication. What's the size? 2 rows and 3 columns. This is 3 rows and 1 column. Can we multiply AB? Yes. What's the resulting one? 2 times 1. Not 2 times 1, 2 by 1. So, the resulting matrix is 2 by 1. That means 2 rows and 1 column. So, you get only 2 values. So, we will see how we can find out 2 values. First, write down the 2 matrices in order 0, 3, 1. Then, first row, first column 0, 0, 4. You get 4. This one 0, 15, 2. 15 plus 2, 17. So, what's the matrix? 4 and 17. This one you are asked to find out 3a minus 2b. 3 times a and 2 times b. Now multiply by 3. 3 times 2 minus 6. 3 times 3 9. 3 times 0 0. 3 times 4 12. 2 times 5 10. 2 times 0 0. 2 times 9 18. 2 times minus 3 minus 6. Now subtract. Minus 6 minus 10 minus 16. 9 minus 0 you get 9. 0 minus 18 minus 18 and 12 minus minus 6. 12 plus 6 you get 18 there. So, what's the resulting matrix? Also 2 by 2. Look at this question. You have given 2 matrices P and Q and you are asked to find PQ and QP. Find the relationship between PQ and QP. So, first we will find PQ. P is 2 0 0 2. Q 3 1 2 4. Can we multiply? We can, because 2 by 2, 2 by 2, these are equal. So, what's the resulting matrix? 2 by 2. So, what you get? First row with first column 6 0 you get 6. 2 0 you get 2. 0 4 you get 4. 0 8. So, that's PQ. QP, you have to write Q first now. 3 1 2 4 2 0 0 2. Here also you can multiply. The resulting matrix is 2 by 2. Now we will multiply. Do it. 6 0 you get 6. 0 2 you get 2. 4 0 4. 0 8 you get 8. Now what can you say about these two? 6 2 4 8, 6 2 4 8. In this case, in this example, PQ is equal to QP. Not always, only this example, this is true. Take this one. A is 1 row, 2 columns, 1 by 2. What's B? 2 rows, 1 column. Can we multiply AB? We can, because these are equal. So, what's the resulting matrix? You get 1 by 1. just one number. So how you get that number? 2 with 3, 6. 1 with 2, 2. 6 plus 2, 8. Find the value of x plus y. So you have given multiplication and it's equal to 12, 18. So we'll check it. 2 by 2 and 2 by 1. So the resulting matrix is 2 by 1. So we can do that. So first multiply these two. First row with first column. 2x plus 3y. This with this, this with this. Then the second one, 3 with x, 3x, 2 with y, 2y. That's equal to this one given. So what are the two equations you can write down? You can write down 2x plus 3y equals 12. And what's the other equation you can write? 3x plus 2y equals 18. So this is first and second equations. Now you need x plus y. So what happens when you add it? Add 1 and 2. Add these two. 2x and 3x becomes 5x. 3y plus 2y, you get 5y. 5x plus 5y equals, add these two, you get 30. Now take 5 out. X plus y equals 30. Divide by 5 both sides. What you get? When you divide by 5, you get x plus y. So what's x plus y? 30 divided by 5, you get 6. The question asks to find out x plus y. So x plus y equals 6. Find the value of x. We'll first do left hand side. Multiplication is there. 2 times 2 and 2 times 1. You get 2 times 1. That means 2 values. 5 times x, 5x. 2 times y, 2y. Here x into 1, x, minus 2 into y, minus 2y. This side 17 and 1 given. Now these are equal. So you can write down 5x plus 2y equals 17. That's my first equation. X minus y, 2y equals 1. Second equation. Now what can we do? We need x. So we'll add the two equations. Plus 2y and minus 2y get cancelled out when you add the two equations. So 1 plus 2, what's the answer? 1 plus 2. So 5x plus x becomes 6x. 17 plus 1, 18. So divide by 6, you get 18 divided by 6 is 3. So the value of x is 3. If you want the value of y, you can substitute to one of the equations and find the y value as well. Example 1, 3 matrices which are named are shown below. So here labeled this one as A, that's 3 by 3 matrix. This is, I'll just write down the order, 3 by 3. B, what's the order? 3 by 1. And here P matrix is 2 by 2 matrix. So first you need to identify the matrix. We use capital letters to label the matrices. Example 2, in a Cartesian plane the coordinates of the points A and B are 0, 5 and 4, 3. Respectively represent this information in a matrix. Name it P. So we can write P equals What's the size? 2 by 2. 2 by 2 matrix. We can write down 0, 4, 5, 3. So this represent, first row represent 0, 4 means x coordinates of A and B. This one represents y coordinates of A and B. Example number 1, write the order of each of the matrices given below. First one, number of rows, 1, 2, 3. Number of columns, 1, 2. Order of the matrix is 3 by 2. Look at the second one. How many rows? 1. How many columns? 3. So what's the order? 1 by 3. Third one, number of rows? 2. Number of columns? 1. What's the order? 2 by 1 matrix. This one, number of rows 2, number of columns 2. This is 2 by 2 matrix. Exercise 19.1. Sarath bought 2 oranges and 3 mangoes. Kamal bought 4 oranges and 1 mango, and Raju bought 1 orange and 5 mangoes from a certain fruit stall. Express the amount of fruits bought by Sarath as a row matrix. So here we'll just write down what it says: Sarath, Kamal and Raju. Sarath, 2 oranges, and so I'll write down this side oranges and mangoes here. 2, 3. Kamal, 4, 1. And Raju, 1, 5. Now we can answer the questions. First one. Express the amount of fruits bought by Sarath. So this is Sarath's as a row matrix. So they are asking just to write down the numbers in row matrix. 2, 3. Then second part, the amount of fruits bought by Kamal as a row. Kamal, 4, 1. Third one, express the amount of fruits bought by Raju. 1, 5. Then fourth part, construct a matrix with quantities of fruits Sarath, Kamal and Raju bought respectively as its rows. So what's the full matrix? You can write down 2, 3, 4, 1, 1, 5. So this is 3 rows and 2 columns. So 3 means 3 people. Sarath, Kamal and Raju. This side oranges and mangoes. Write the order of each of the following matrices. Write down 3 rows, 2 columns, 3 by 2. 2 rows, 3 columns, 2 by 3. This one, 3 rows, 1 column. That's a column matrix, 3 by 1. This one is a row matrix, 1 row and 2 columns, 1 by 2. This one, a row matrix, 1 row, 3 columns, 1 by 3. This one, 2 by 2. From the matrices given below, select the row matrices and the column matrices. Is it a row matrix? This is 1 row, 3 columns. When you get 1 row, that's a row matrix. So that's a row matrix. Q, 2 rows and 1 column. one column is there, that means a column matrix. Or one row and two columns. One row is there, that's a row matrix. This one column is there and three rows, 3 by 1, that's a column matrix. This one row and 3 columns, 1 by 3, that's a row matrix. This one, 2 rows and 2 columns, not a row or a column matrix. Question number 4. From the following matrices, select and write down the square matrices. How we identify square matrices? Same number of rows and same number of columns. This is 2 by 2, this is 3 by 2, 3 by 3, 3 by 3 here, 3 by 3, 3 by 3 and 2 by 2. So what are the square matrices? A, C, D, E, F, G. All are square matrices. Symmetric. How we identify symmetric? When you take the main diagonal, the other elements are the same. So A is a symmetric matrix. So only for square matrices you can find out symmetric matrices. These are not equal. What about this one? When you draw this line, elements are equal, so D is a symmetric matrix. When you draw this line, the other elements are 0. So E is a symmetric matrix. Draw the line here. All the elements are okay. So F is also symmetric. This one, this is not symmetric. Identity matrix means leading diagonal terms. Main diagonal elements are 1s and all the other elements are 0s. So out of these only E is an identity matrix. Highlight the diagonals of the square matrix. So this is the diagonal. Example number 1. Praveen and Tharindu are 2 bowlers in the school cricket team. The number of wickets they took in the years 2014 and 2015 in one-day and two-day matches are shown in the table given below. Wickets taken in one-day matches and wickets taken in two-day matches. We'll take this one and write in a matrix notation. So I can write this one as 21, 23, 15, 16. So that's, I'll take A. So what it means, this is Praveen's score and this is Tharindu's. These are the 2 years. Then this table I can write as, we'll write B. This is wickets taken in two-day matches, but still Praveen and Tharindu. So 2014, so 14, 16, 9, 19. So if you want the total number of wickets taken by Praveen and Tharindu, what can we do? We can just add the 2 matrices. So I can do A plus B is equal to 21, 23, 15, 16 plus 14, 16, 9, 19. What's the answer? 21, 14, you get 5 and 3, 35. This one 9, 3, 39. This one 24 and 35. So what it means? So this means the first row represent Praveen. So Praveen's total number of wickets in 2014 is 35. Total number of wickets taken by Praveen in 2015 is 39. Total number of wickets taken by Tharindu in 2014 is 24. Total number of wickets taken by Tharindu in 2015 is 35. So when you take the matrix, you can identify the total when you take the addition. This is another example just to subtract. Can you subtract these two? 2 by 2 matrices, you can subtract. Both are 2 by 2. So we'll subtract. How we do A minus B? You first write A, then B. Corresponding elements you subtract. 5 minus 1, you get 4. 9 minus 4, 5. 2 minus 6, minus 4, and 3 minus 0, you get 3. So you get A minus B as 2 by 2 matrix. Another example just to subtract, x minus y. First write down x, 2, 2, 2, 2, 2, 2, that's 2 by 3. Then subtract 1, 0, 0, 0, 1, 0, 0, 0, 1, that's an identity matrix. The diagonal terms are 1. That's 3 by 3. Can you subtract? You can't subtract because the number of elements and rows are not tally with the other one. This is 2 rows and 3 columns. This is 3 rows and 3 columns. The order is not the same, so we can't do subtraction. Equality of 2 matrices, we discussed this before. If there are 2 matrices A and B with the same order, I'll take m into n, m number of rows and n number of columns, same order. And if all the elements, corresponding elements are the same, we can say A is equal to matrix B. So equal matrices, when corresponding elements are equal with same order, we call it equality of 2 matrices. Exercise 19.2, simplify the following matrices. Add the 2. So 2 by 2, 2 by 2 you can add. 2 plus 2, 4. 3 plus 4, 7. 1 plus 3, 4. 4 plus 5, 9. Take the second example. This is 1 row, 3 columns. So you get the same order. 3 plus 2, 5. Minus 2 minus 2, minus 4. 3 minus 4, minus 1. This one, 6 plus 2, 8. 4 minus 4, 0. This one, same order given, so you can add the matrices. Minus 2 plus 3, 1. 0 plus 1, 1. 3 minus 2, you get 1. Add these two. 2 plus 3, 5. Minus 2 minus 1, minus 3. 3 minus 2, 1. 2 plus 1, 3. 3 plus 2, 5. 4 minus 2, 2. These two. 3 minus 2, 1. Minus 2 plus 2, 0. 1 minus 1, 0. 0 plus 1, you get 1. So, that is an identity matrix. This one, add corresponding elements. 2 plus 0, 2. 5 minus 4, 1. Minus 1 plus 4, 3. 3 minus 4, minus 1. 4 plus 0, 4. 6 minus 1, 6 plus 1, 7. 2 plus 1, 3. 4 plus 3, 7. 1 plus 0, you get 1. Now take this one. 5 plus 2, 7. 4 plus 3, 7. 2 plus 5, 7. 2 plus 5, 7. 3 plus 3, 6. Minus 3 plus 10, you get 7. Simplify the following matrices. So, that means you are asked to subtract and write down the final answer. So, what you get here? 4 minus 2, 2. 3 minus 2, 1. 2 minus 1, 1. 5 minus 2, 3. 6 minus 2, you get 4. 7 minus 1, you get 6. Second one, minus 3 minus 3, minus 6. 5 minus 8, minus 3. 8 minus 2, you get 6. Here, be careful with minus minus, minus minus becomes plus. 3 minus minus 2, plus 5. 2 minus 3, you get minus 1. Minus 1, minus 5, minus 6. 4 minus 2, you get 2. Now take this one. 5 minus 2, 3. Minus 3, minus minus 4. You get minus 3 plus 4. You get 1. Minus 2, minus minus 2. You get minus 2 plus 2 get cancelled out and you get 0. This one, 5 minus 4, 1. 3 minus 3, 0. Minus 2 minus minus 2. Minus 2 plus 2 becomes 0. 4 minus 1, you get 3. And this one, what are the numbers? 6 minus 3, you get 3. 3 minus 2, 1. 2 minus minus 2, you get plus 4. 2 plus 2. 4 minus 2, 2. 3 minus 0, 3. 5 minus 2, 3. 3 minus 1, 2. Minus 2. Minus minus 5 becomes minus 2 plus 5. That means 3. 1 minus minus 4. 1 plus 4. You get 5. Question number 3. If these two addition is ABC, find the values of ABC. So, these are two row matrices. Just you can add it. When you add it, what you get? 2 plus 2, you get 4. 3 plus minus 1, you get plus 2. 1 plus 3, 4. So, if this is equal to A, B, C, what's their value? A is 4, B equals 2 and C equals 4. You can compare the corresponding elements. If these two subtraction is equal to A, B, C, D, find the values of A, B, C and D. So, we will do the subtraction. 3 minus 5, you get minus 2. 2 minus 4, minus 2. 4 minus 3, 1 and 1 minus 2, minus 1. That's equal to A, B, C, D. So, what's A? A equals minus 2, B equals minus 2, C equals 1 and D equals minus 1. So, you can compare the corresponding elements. If these two addition is equal to this one, find x, y and z. So, we will add these two. 5 plus x, 5 plus x. 3 plus 2, you get 5. 2 minus 1, you get 1. 4 plus y here, 1 plus 1, 2, 2 plus z. That's the addition of these two matrices. Then this is equal to 8, 5, 1, 2, 2, 3. So, that means this one is equal to this one. So, we can write 5 plus x equals 8. So, what's x? Take 5 to the other side, you get 3. 8 minus 5, you get 3. This element you can compare with this one. 4 plus y equals 2. So, what's the y value? 2 minus 4. Y equals minus 2. Now, the third one, to find z, I can compare this one with this one. So, how can I write? 2 plus z is equal to 3. So, z equals 3 minus 2, that's 1. Two matrices given and that's equal to identity matrix. Find the values of x and y. So, we will do the left hand side. 2 minus x. Minus 3, you get minus 6. 1 minus y and this one 2 minus 1, you get 1. So, that matrix is equal to this. Now, look at these two matrices. Can we compare? There's a mistake. When you do this calculation, you get minus 6. This is not same as this. So, these two are not equal matrices. So, because of that, you can't compare these two. If this is equal to minus 6 or 0, you can compare. Shall we check with addition? If this is addition, what happens? 2 plus 1, this is 3. Then again you can't compare. So, there is a mistake in this question. If this is minus 6, I can compare. So, I will do it if only if it is minus 6. So, 2 minus x minus 6 is there. If this is 0, I can compare. 0, 1 minus y 1. If this is equal to 1, 0, 1, 0, 0, 1, 0, 1, I can compare with this one with this one. So, 2 minus x equals 1. So, x equals 1. If this is equal to this one, I can compare this with this. 1 minus y equals 0. So, y equals 1, but not in this question. It's wrong because you can't compare these two matrices. These are not equal matrices. Here we did this before, multiplication of a matrix by a number. Just to revise this, if this is 3 times any matrix, we will take 2, 5, minus 1. We have to multiply all the elements by the number given. So what's the matrix you are getting? 3 times 2 6, 3 times 5 15, 3 times minus 1 minus 3. So when you are multiplying by a number, just multiply all the elements in the matrix by that number. Take this example. You have given x, y, asking you to find out 3x minus 2y. So 3 times x minus 2 times y. First multiply by 3, you get 6. 3 times 4 12, 3 times 1 3, 3 times 0 0. Minus 2 times 5 10, 2 times minus 2 minus 4, 2 times 2 4, 2 times 1 2. Now we can subtract. 6 minus 10 minus 4, 12 minus minus 4. You have to add 16. 3 minus 4, you get minus 1. 0 minus 2, you get minus 2. Exercise 19.3. Simplify the following matrices. So multiply by a number. So how you do? 3 times 3 9, 3 times 1 3, 3 times 2 6, 3 times 4 12. This one just multiply by 4. 4 times 2 8, 4 times 3 12. This one multiply by 3. 3 times 2 6, 3 times minus 1 minus 3, 3 times 3 9. 3 times minus 3 minus 9, 3 times 1 3, 3 times 2 6. This one multiply by 2. 2 times 2 4, 2 times 0 0, 2 times 3 6. This one multiply by 3. 3 0 minus 6, 9 minus 3 6, minus 9 6 0. Multiply by minus 2 here. Minus 6, minus minus plus, plus 4, minus minus again plus 8, minus 2. Find A, B, C and D if 3 times this is equal to that. So first we will multiply this by 3. 3 times 4 12. 3 times minus 1 minus 3. 3 times 2 6. 3 times 3 9. That's equal to A, C, B, D. Now corresponding elements you can equate. A equals 12. B equals 6. C equals minus 3 and D equals 9. Find the values of x, y and z if 4 times this is equal to this one. So multiply by 4. 4x, 4y, 4z. That's equal to 8 minus 12, 2. Now you can compare the elements. 4x equals 8. So what's x? 8 divided by 4, you get 2. 4y equals minus 12. So what's y? Divide by 4, minus 3. 4z equals 2. So what's c? 2 divided by 4, that's half. Question number 4. Find the values of x, y, a and b if this is equal. So first we will multiply by 2. 2 times 5, 10. 2 times x, 2x. 2 times minus 2, minus 4. 2 times 9, 18. That's this one, minus. Now multiply by 3. 3 times y, 3y. 3 times minus 5, minus 15. 3 times 4, 12. 3 times a, 3a. So what's the final value when you subtract these two? You get 10 minus 3y, 2x minus minus becomes plus. 15 minus 4 minus 12, you get minus 16, and the other one 18 minus 3a. So this is equal to 55b0. Now we can compare. I can compare this one with this one. So 10 minus 3y equals 5. I'll take 3y to this side. So 3y equals 10 minus 5, that's 5. Y equals 5 over 3. This one I can compare with this one. 2x plus 15 is equal to 5. 2x equals 5 minus 15, you get minus 10. So what's x? Divide by 2, you get minus 5. This one I can compare with this one. So b equals straight away minus 16. And last one, I can compare this one with this number. So what do you get? 18 minus 3a is equal to 0. Take 3a to this side, 3a equals 18. So what's a? 18 divided by 3, you get a equals 6. Example number 1, AB, find AB if A equals this and B equals this. First you need to check whether you can multiply. A is 1 by 2, B is 2 by 1. These two numbers are same. You can multiply. The resulting matrix is 1 by 1. So we'll do that. AB 5, 2, 3, 1. So you get only one value. How you get the number? 5 times 3, 15. 15 plus 2, 17. Example number 2. X is this, y is this, then show that x, y is defined and find it. Is y, x defined? So we'll do it. X, y. First we'll need to check whether you can find 2 by 2. Why? 1, 7 means 2 by 1. Can we multiply? Yes, we can multiply because the number of columns in the first one is same as the number of rows in the second one. So you get 2 by 1. So we'll find it. So you get 2 by 1 means 1 column, 2 values. How you get the first number? 4 times 1, 4, 6 times 7, 42, 42 plus 4, 46. Second number, 2 times 1, 2, 3 times 7, 21. 21 plus 2, you get 23. Now, can you find out yx? We'll check. Y is 1, 7 and x is 4, 6, 2, 3. This is 2 by 1. This is 2 by 2. These two are not equal, so you can't multiply. All right. Cannot multiply. Exercise 19.4, simplify the following matrices. So, these are multiplications. Before you start, check whether you can multiply. 1, 2, 2, 1. Yes, you can multiply. You get 1 by 1 means just one value. How you get that value? 3 times 3, 9. 9 plus 4. 9 plus 4 is 13. Do the next one. This is 1 times 2, 2 times 1. We can multiply. What's the resulting matrix? 1 by 1. Now do the calculations. 3 times 2, 6. 2 times 4, 8. 8 plus 6, 14. This one, 2 by 2, 2 by 1. What's the resulting matrix? 2 by 1. That means 2 rows and 1 column. Get the value. First one, 2 times 2 minus 1 times 1, minus 1. 4 minus 1, you get 3. 0, then minus 2, you get minus 2. 2 by 1 matrix. This one, 1 times 2 into 2 times 2. So you can multiply. What's the resulting one? 1 times 2 means 1 row and 2 values. 1 times 2. How you get the value? First one, 2 plus 10, 12. Second number, 1 plus 0, you get 1. This one, 2 by 2 and 2 by 1. Can we multiply? Yes. What's the resulting matrix? 2 times 1. 2 rows and 1 column. What's the first number? 2 times 3, 6. 6 plus 8, 14. Next one, 3 times 1, 3. 2 times 1, 2. 3 plus 2, you get 5. This number, you get 2 by 2, 2 by 2. That means resulting matrix also 2 by 2. You get 4 values. What's the first number? 3 plus 4, 7. Minus 6 plus 2, minus 4. This value, minus 2 plus 2, 0. Minus minus plus, plus 4 and plus 1, plus 5. This one, 2 by 2, 2 by 2. So the resulting also 2 by 2. So multiply 2 with 1, 2, 0, you get 2. 0, 0, 0 here. 0 with 0, you get 0. And here 0 and 2, you get 2. Next one, 2 by 2 and 2 by 2. So here this sign means multiplication. The resulting matrix also 2 by 2. How you get the 4 numbers? You get 4 numbers. 3, 0, you get 3. 1, 0, you get 1. 0 with 2, you get 2. 0 and 2, you get 2 here. Next one, 1 times 2, 2 times 2. You can multiply. The resulting matrix is 1 by 2. 1 row, 2 columns. First number, 2 with 4, you get 6. 4 and 2, you get 6 again. This one, 1 times 2 and 2 times 2. Can you multiply? Yes, this is 1 times 2. So 1 row, 2 columns you are getting. What's the first one? 2 times 3, 6. 6 plus 6, you get 12. Next number, 2 times minus 2, minus 4. Minus 4 minus 9, minus 13. Second question, find A and B if these two are equal. Can we multiply? This is 1 times 2, 2 times 2. So you are getting 1 times 2. That means 1 row, 2 columns. 2 times 3, 6. 6 plus 3, 9. Next number, 2 times 0, 0. 3 times 2, 6. So if this is equal to AB, what's A? A equals 9, B equals 6. Question number 3, A, B and C are 3 matrices. Fill in the blanks in the following table. Order of matrices are given, 1 times 2, 2 times 1. What's the resulting matrix C? So these two are the same, so you get 1 by 1. This one, you get 2 and 1 here. So this should be 2 to multiply, and this one becomes 2 by 1. Here, these two numbers should be the same. And the resulting matrix is given 1 times 1. So that means this is 1. Here, resulting matrix is 2. That means this number and this number should be 1 and the middle one should be the same. That's 1. Then this one, 1 is there, resulting matrix. So this becomes 1. 2 is there in the second one. So that should be 2 and these numbers should be the same. That's 1. Question number 4. You are asked to find out P into Q. PQ. Write P, write Q. What you get? This is 1 times 2, 2 times 2. What's the resulting matrix? 1 times 2. That means 1 row, 2 columns. We'll find out the values. 2 times 2, 4. 4 minus 1, that's 3. Next number, minus 2, minus 2, minus 4. Second one, we need to find PR. What's P? 2 minus 1. What's R? 2 and 1. This is 1 times 2. This is 2 times 1. Can we multiply? Yes, we get 1 times 1 means just a number. What's the number? 2 times 2, 4. 4 minus 1, that's 3. Third part, Q into R. Q is 2 minus 1, 1, 2. R is 2, 1. Can we multiply? 2 by 2 and 2 by 1. We can. So the resulting matrix is 2, 1. 2 rows, 1 column. How we get the numbers? 2 times 2, 4. 4 minus 1, 3. 2 and 2, you get 4. Question number 5. Find AB. Write down A, write down B. Now, this is 2 by 2, this is 2 by 2. Can we multiply? Yes, we can multiply, and the resulting matrix also 2 by 2. Now, we will see what are the numbers, elements you are getting. 6, 0, you get 6. 4, 0, you get 4. 0, 2, you get 2 here. 0, 2, you get 2 there. Second one, find BA. Write B first. 3, 2, 1, 1. and then A. A is 2, 0, 0, 2. So the resulting matrix also 2 by 2. Now find out the values. 3 times 2, 6. 6, 0, you get 6. This is 0, 4. 2 with 0, you get 2, 0 and 2, you get 2 there. Then what is the relationship between AB and BA? Look at carefully. Both are the same. So AB is equal to BA in this question. Question number 6. CD given, find CD multiplication. So first we can write C and then D. 4, 3, 2, 5. So this is 2 by 2, 2 by 2. So the resulting matrix also 2 by 2. 4 elements you are getting. We'll do the multiplication. 4 times 3, 12 and 4, 16. 3 times 3, 9 plus 10, 19. 4 plus 8, 12. 3 plus 20, 23. Then DC. DC, first you write D. 4, 3, 2, 5. And C next. 3, 2, 1, 4. So 2 by 2, 2 by 2, you are getting 2 by 2 as well. How you get the answers? 12 plus 3, 15. 8 plus 12, 20. 6 plus 5, 11. And 4 plus 20, 24. In this chapter, we covered all the exercises and examples, and remember in this chapter how to multiply, add, subtract matrices.